So as Stina mentioned, we both work for Edument. Edument is a knowledge-based company. We do both consulting and teaching, and we spend a lot of our time working with different clients that have specific problems. And so tonight's talk is really based off of things that I've learned from different clients that are working with testing, and in particular, Angular testing. So my name is Stephen. I'm from Canada. I've been living here around 5 years. I've spent a couple of years commuting from Sweden to China for one client every second month in China. And I've also been working with quite a few companies in Germany and in Slovenia, in Iceland, in different places, and in Canada as well. So this talk is really based around practical experiences. Whenever we talk about the web, we kind of need to acknowledge that at the moment there's sort of two camps. In one side we have all of the React guys, on the other side we have all of the Angular guys, and somewhere in the corner we have Evan with Vue. So when we talk about this, it's important that we understand that different people have different opinions, and those color their experiences and what they want to talk about. And while we're going to be talking about Angular tonight, it's also important to realize that if we zoom in on this picture, I'm pretty firmly in the Angular camp. So I'm hiding in the back there. So currently I'm working on a project. When I arrived there, they had quite a few tests, but the tests were not providing a lot of value. They had around 150, somewhere between 150 and 200 tests, and they were taking around 3 minutes to run, and most of them are just the tests that are automatically generated, that just instantiate the component and don't do a lot else. And these are unit tests that we're talking about, right? Today, those tests are taking less than 15 seconds to run, and we've added about 30% to the test count. And those tests are actually starting to test real things in our components. And I think that the lessons that have been learned from this project are valuable for others as well, which is why I want to talk about this. The other thing that I noticed is when I was talking with my new colleagues and said, oh, but why don't you just look at these examples? When I went online and tried to find good examples of how people are testing with Angular and doing it in a concrete way, it was really hard to find good examples. So when I started writing this talk, I thought, okay, I will go and find some good examples to point people to make it a little bit easier for you. So let's go and look for some. So I went on Google, as we do, and I searched for top Angular projects. And I found this nice list. They claim that they've gone through 2,500 projects looking for different top projects that are open source. The first thing I did is I kind of eliminated things that were just libraries. I looked for things that were actual applications that were running, because that would be more similar to what we were doing. So I found this list here from that 25 list. We have this real-world example app that claims that it's going through everything in a really real-world way, following best design practices. We have a travel guide app, a media player, and we have Angular I/O, which, as many of you probably know, is the documentation for Angular. And they believe in dog fooding, so it's made by the Angular people, and they are building their app in Angular, so surely we will have good tests in some of these. So I went on GitHub. I found the Angular example app. It has almost 2,500 stars, almost 1,000 forks, claims to be the exemplary Angular app. So I forked it, ran the tests, and here we can see our Karma window. So for those that don't know, this is Karma. The unit testing in Angular is done through the web with Chrome. And so here we can see they have absolutely 0 tests in their example application. So we're not off to a really great start. So I grabbed the next project. Yatram. We have 300 stars, 100 forks. Cloned it, fired up the tests. They're missing some of the Istanbul dependencies that come from the default CLI. So we're not doing very well on finding our tests. So we go for the media player. 600 stars, quite a bit of interest. And they have 70 tests. So we finally found some, right? So you can see that it's not super easy to find the tests that we're looking for. So let's look at Angular I/O. We go on Angular I/O. We have 1,000 stars, 900 forks, something like that. Made by the Angular people. Oh, that's not good. No tests to find. So it's a bit disappointing. But of course, those of you that have worked with Angular some will say, hey, you're the React guy, you're cheating. This is the old archived version of Angular I/O. You should use the new one. So we grabbed the new one. It's buried in with the Angular code as well. It lives in the AIO directory. Now we have maybe a more appropriate count. So, yeah, 10,000 forks, 42,000 stars. Clearly people like Angular. And we have 600 tests. So we have something that we can use for a benchmark. So when we try to speed up tests today and we look at how we can make our tests run faster, the benchmark that I've used is the Angular repository and the codes that they're writing using Angular. So my hope is that these are among the best tests that exist for Angular. And if we can speed those up, that being able to speed up these tests will be able to give you a gain in your apps, right? So has anybody here used Karma for testing? Some hands, a few people? Yeah. So let's just do a quick demo. We will look here. Yeah, that is big enough. All right. So what Karma does, what they're doing here is they do some checks first. They check which environment you're in. They make sure that you have a node version that's compatible, that sort of thing. So they're adding a few seconds to the tests already. So now Karma uses compiling. So it's going to go and compile each component so that it doesn't need to compile it for each test. Once it's compiled the components, it's going to go and take those components and it's going to run them in Chrome. So here we see it firing up a Chrome window, and we'll start to see these tests flashing by. And keep in mind these are unit tests, not integration tests. And so when we unit test, we're interested in the unit of code. We're not really interested in does it work in the Chrome browser or the Firefox browser. We should push that out to our end-to-end tests or to our integration tests or to our manual testing if we want to test that, right? So this is the Angular AIO site and all of their tests. So you can see they're testing different things can be rendered correctly, and they're testing with different dock renderers, that sort of thing. And so they have one really large file that takes quite a long time to run, and then once that goes, then we get all of the small ones. We can also see we have a few small stars. These are skipped tests. So when we look at this a bit later, there's 3 tests that exist in the repository that have no test body, and so they're just skipped by Karma. Right, so the tests have run. We have 1 minute and 18 seconds for the full test run, right? So this is the Karma tool that we're hoping to beat. So before we go talking about how to speed up the test too much, let's talk a little bit about how we identify what to test. Because one of the problems that I realized is when you discuss unit testing components with people, it becomes difficult to say, what is a unit? What exactly should we test in a component? Are you fingerprinting your code? Will this test be able to survive a refactor? And those are things that we want our tests to do, right? We want to have these quick tests that run, we get really quick feedback. We also want to get value from those tests. And if we're not getting value, then there isn't really a point in having the tests. So today we're just focusing on component unit tests. We're going to leave alone service unit tests. I will mention them very briefly. We're going to leave alone integration and end-to-end and manual testing. And I want to be very clear. There's nothing wrong with these types of testing. And they are important, but that's just not what this talk is about. So please don't think that I don't think that they're important. They are, but today we're not going to focus on them. So has anybody seen this test before? A few people? So this test is generated by the Angular CLI. And basically it just checks that your component can instantiate, that it exists. Now, if you went to a company and every test for a class just said new and then the class name and then is defined, you probably wouldn't say, oh, they have really good unit testing. I mean, they've just kind of looked, oh, this component exists, right? And while this provides a little bit of value, we want to go deeper than that. We want to start to have tests that are not just this, but actually look at what is happening in the component. So we're going to use a simple example for this. My colleague David, who's sitting up here, has made this GitHub battle app. Oh, if I had Wi-Fi, this would work better. My apologies. Where's my hotspot? There it is. All right, so it's a very simple application. We've not involved our UX team. They are appalled. First thing that we need to do is we need to sign in. And so we're using Firebase for the authentication. We need to sign in because otherwise GitHub will limit the number of requests that we can make. So once we've signed in, we have a pretty simple application. We're going to put in 2 GitHub usernames, and whoever has the most stars will be declared the winner. So I will put mine, and if somebody wants to suggest theirs, we can play. Yeah, how do you spell it? Yeah. Perfect. So we'll load yours. So now we're going to GitHub collecting the stars. Our friend Farhan here has 3 stars across 3 repos. Oh, 1 for each. That's pretty good. And we'll load mine up. I have 57,000 stars. Sweet. So this is our simple application. We're going to be using this throughout our tests. Fortunately, because I'm the one presenting, it's really easy for me to cheat and, give myself lots of stars. So I don't actually have 57,000 stars. So, this is how our app is laid out. This is the architecture for our application. So, we have 4 components here, and we have 4 services. And this is a little bit contrived, it's a little bit more than you might do, but at the same time, it's not entirely unreasonable. So we have an app component that's responsible for checking the authentication with Firebase and logging in, and it uses the auth service to do that. We then have a battle component that is rendered by the app service, and it's responsible for rendering 2 different combatants and putting on that gold highlight that we saw, or yellow highlight, to show the winner. And then each combatant is responsible for collecting the details and for rendering the details once they're available, right? And over here, we have our URL service and our GitHub service, and then we have a battle service which calculates the things from the GitHub service, right? But we're going to focus on this side. So if we were to draw that in a bit of a kind of React-y way, we can draw it something like this, right? So we have an app that has a battle, that has a combatant, that has a component detail, right? So when we're testing components, components are a unit. When we unit test components, we want to look at a component. So what does this mean? This means that when we're testing, we want to avoid fingerprinting our code, and we want to test the component in isolation. So let's take a look at the battle component so we can see what exists in our component. Right, so here we have the TypeScript file for the battle component. Now, when we look at this file, if we were doing a code review and trying to decide if the person had written enough tests or had written good tests, what things would we look for in this file to decide if the testing is good? Can someone suggest something from here? What is the surface API for a component? David, do you have a suggestion? Yeah? So we're doing something with the winner class? I would say that here we're using 2 child components, and that we should test that we use our children correctly. So we don't want to test that the children's behavior is correct, but we want to test that we use the children correctly. And specifically, when we look at this, we can see that we have an input to our child here and an output here. And these are recognized by the square brackets and the round brackets. So right away, we can look at a file and say, have you tested this? This is the output from your component. This is part of your Surface API, right? And down here, we can see that we don't have any external inputs and outputs. We don't have a constructor, and we don't have any input or output here. So for this one, I would say that we want to look mostly at how we use our child components, right? So we have inputs, outputs. We're going to build a little list. We're going to try and have a list of things that we can pin on our cubicle wall or on the wall behind us and say, when I look at a code review, yes, this is here. Yes, this is here. No, this isn't. Why not? Right? And of course, we have our in-out component is the other one that we haven't mentioned. And there's a nice thing to remember this. If you're trying to remember the order, you put the bananas in the box. Right, let's look at the combatant component and see if we can identify some things to test there. So here we can see we have our template for our component. We can see that we have some template logic here. This is quite likely something that we're going to want to think about testing to make sure that we don't instantiate the error if there's no errors, that we show the error if there is errors, that sort of thing. We can also see that very clearly marked here, we have an output. So this is our component would have an output to the class above us, right? And so this is something else that we're going to want to test. This is part of our surface area, right? When we talk about testing these, we have a few options for our tests, and a few options for finding these components. And so one of the things that we've found that works really well is we add these QA classes here. These classes are used specifically for finding the component in tests. So we use those directly. We can find that div immediately in our test. It becomes a one-liner. If you're worried about performance, you can strip those out in Webpack or use an attribute instead. They're both very valid options. But I can say that this style of testing where you start adding a QA class specifically for that, and that you don't use that anywhere else, means that you're not going to be writing styles against that, so you don't have to worry about people changing them or moving them around to get their style to work. And it means that you can write tests in a few seconds instead of several minutes of trying to dig in and find this has a subcomponent of this and so on, right? So you do a lot less DOM parsing. And so this is a tip that I can say has really saved me a lot of time since I started doing it. So we have some new additions to our list. We found an output in there. Oh, I forgot to mention, we have a constructor as well. Hiding in there, we have a constructor. We can see here, this constructor is taking a battle service. So this is how we get a dependency. So this component has a dependency on the battle service, right? So we have a dependency, which we found in the constructor on the second round. And we also have some template logic, some conditional rendering. And I would say that template logic, when we're discussing what to test, is probably the most difficult and the most subjective to decide what things are fair for testing and which things we probably want to leave out of our tests because they're just going to change every time somebody changes around the component. So we end up with a testing list something like this. We have a couple of other things that have snuck in, the view child and local variables. But this list here is a list that you could pin up on the wall or put on a code review and say, have you checked these things? They're really what we want to look at for a component to test, right? I don't want to go too deep into how to test each of these, so I will put a couple links here. I'll make the presentation available. If anybody is interested, just come and find me when we're having beer later, and I can set you up with a link or get your email. But Angular IO has really fantastic documentation on how to test inside of our components. They talk a lot about general component interaction and how different components interact and how to test that interaction and how to test in general. Right. So, who here has done shallow rendering? Couple hands, yeah. Are you from the React side or the Angular side? Ah, yes. So, shallow rendering is quite popular in React using a library called Enzyme. And so, when we shallow render, when we're interested in rendering, let's say, the battle component for our tests, the idea in shallow rendering is that we render the battle component and we kind of cut this dependency. So we no longer render the combatant or the combatant detail because we don't need those to decide if the battle component works as a unit, right? We're not doing an integration test, we're doing a unit test. So we should test this unit in isolation, right? And the same with a combatant. We would not use a real service, we would not use a real combatant detail. We just want to render that component and test it in isolation. So let's take a look at a component spec. So this is how we write tests for Angular, part of it. This is how we set up the test module, right? So the easiest way to get rid of that component is we define another component with an identical selector. So now when Angular goes to render this, it will find this fake one instead, and it will use it in its place. And you can see that we've added a fake emitter, which means that we can still emit things from that. We can still mock the outputs of this component, and we can use those for testing, right? And then we need to, of course, declare our fake component here. And we can see that in our full test file. So here, we get the battle component, which is the one that we're going to test. Here, a little bit up, we set up our fake combatant, and then we pass that into our test module config. Right? So now we're no longer going to use the real combatant component, and that also gives us the ability to emit things. So here we can see that we use, here we're tracking down our two combatants that are being rendered. We find those, and then we use them, and we can emit things from them. So this is essentially mocking if they said they had 456 stars, for example. Right? So it becomes very easy to test these units. And we just find it, you can either find it, so here we're using the combatant type to find the CSS. If you were using the QA type, if you just had one somewhere really deep you want to find, you can put a QA class, and then you'd have .QA combatant or something like that, which makes it really easy to find things. So this can get very tedious very quickly. So in several of our components at work, we have, I don't know, maybe 10 subcomponents that they render. And when you have so many, can you imagine that you're then making all of these mocks, and let's say that they have 5 inputs and outputs. That means that for each of them you need, it's a lot of, boilerplate code that we need to write. So we have a few options to deal with that. The first is the no errors schema. And the naming is a little bit poor. It does produce no errors, but it should probably be named ignore errors. So essentially what happens is when Angular goes and renders your component, if it finds a selector that it doesn't recognize, it goes, oh, I don't know what this is. Oh, I don't care. And then it continues on. But that said, it does still mean that we can find these components. So it renders something empty in their place, essentially. However, we cannot do the mocking that we saw earlier. And so this means that if you just want to see, yes, it rendered this component, this might work for you, and it will save you from writing that boilerplate. But if you want to actually mock the component, that won't really help, right? So when we were working on the project, I started looking around for things that could help out with this, and I found this helpful library. It's called ngmocks, and essentially it looks at the component's definition, and it creates all of the inputs and outputs that the component has, uses the same selector, and creates an empty component in its place, exactly like what we did earlier, but without us having to do any of the work. So how do we use that? We go to ngmocks, we suck out the mock component and mocked component. This is just for TypeScript, so we have the correct types a bit later. Really, we only need this one to begin with at least. And then when we declare it, we just say mock component, and we pass in our real component, and it will generate that code that we wrote earlier. So works great. They also have mock declaration and a few other handy things. So if you're writing Angular code and you want to cut down on how much boilerplate you're writing, we've had really good luck with this so far. And I've not found it, so far I haven't found so many use cases that it doesn't work for. I'm sure that somewhere buried deep there is some, there always is. But it's gotten us a long way. And keep in mind that if you're using this, you can still mock things manually if you need to. So if it doesn't provide what you need, you can just add something on top. But this is a great way to kind of knock out some of your dependencies. And then, of course, we can find it, and it's gone and created that output for us, so we can emit how many stars were there, right? And the mocked component type is just used here for TypeScript, so that we get the correct types. So if you have strict type checking turned on, this will help you out. Right, mocking services. I said that we wouldn't talk too much about services, but of course we have to mention how to mock them. In this example, we're using Synon. Jest has its own stubbing functionality built in once we start talking about Jest. Karma uses Jasmine, which also has its own stubbing functionality built in. So you can choose if you want to use Synon, which is quite a handy library. I know David wrote this particular bit of code, and I know it's one of his favorite libraries because it appears in every project that I come across of his. But it's quite handy. So if you're looking at this, what we've done here is we've created essentially a fake observable, and then we return that fake observable in our fake battle service, and then we need to provide that. So one of the things that I really like about Angular is it has a dependency injection framework built into it, right? So normally in our providers, we would just have something like battle service, comma, and then the next service. Instead, we can pass in an object with the provide key and the service that we're going to be replacing, and what to use instead of the real service, right? So if you pass the real service for both of these, it's exactly the same as just passing the real service. Here we're saying replace our real service with our fake one. And then when it calls the constructor, it will pass this in for us. So we don't have to do anything else. And that's really handy. I mean, we can just test directly. It's a plus. So far we've seen that Karma runs in the browser, right? And of course, this leads to problems very quickly. One of the problems that we had in our team is we have a CI farm living somewhere. I don't know where. I assume it lives in the forest with some trolls taking care of it. And so we have this browser dependency of Chrome that we need, or Firefox. You can choose different things for Karma to run in. But very quickly you realize, okay, I have the wrong version of Chrome, or this guy has this version and this one has this one. You know, we're having some dependency issues. And our CI farm, we're not allowed to install software because many teams use that. So we can't go and change the version of Chrome because it might break something for someone else, right? So has anybody here used Puppeteer? One? Yeah. So Puppeteer is a headless version of Chrome, and it's provided via NPM. So what this means is that NPM will download Chrome for you and save it in your node modules folder, and then you can run it from there. And this is really fantastic because this means that if you want to just run Chrome, you can just add the Puppeteer dependency. It's in the node module, or it's in the package.json. When you do npm install, it will pull it down and make sure it's there. So you never have to worry about a new developer coming and not having Chrome or Firefox or whatever browser you're testing with. It's just there. And you also don't need to talk to the people that maintain your build servers if you need to get that in place. One of the really great things about Puppeteer is it can do so much more than just run Karma tests. I've used it for screenshotting, for example, to build like user documentation. So even though it's headless, it still renders everything, which means that you can still screenshot it. So if you have automated tasks that you run in the browser, I would really highly suggest checking out Puppeteer as an option to run them. Once you've installed it, of course, it ends up in your package.json. In our Karma conf, we need to add a small thing here just saying that we're going to use Puppeteer and get the executable path, and we just switch to use the Chrome headless browser instead of the custom Chrome one. So if we take a look at that, we can get a time for it as well. So I have Puppeteer installed, so this test is not as interesting to watch because it's just going to go and run in the background somewhere. But this is also really good because it means that it's not it doesn't need as much memory to run. It's a little bit less intensive on the computer. And it's quite nice to work with. So once again, we see it compiling. I think we have about a minute for it to run. Does anybody have any questions while we're watching Puppeteer run? No? All right. I just want to get a time so we can see how we're doing. What was the first one? 118, something like that? Yeah. See if we can beat things a little bit. In my testing so far, I found that Puppeteer runs roughly the same speed, but ever so slightly faster. But you're not going to get a really big speed up with this. But it is worth knowing that it's there. And we saw, I don't know, a second or two over a minute and a half, something like that. So it's fired up headless Chrome, and you can see it's executing these tests in the background. And so this works really great. If you're working with Travis CI or something, great way to run your tests if you need a browser. And also a great thing to think about when you do integration tests, which really should run in the browser. And I want to be clear that with unit tests, in my experience, we want to test the unit. We're not testing how it works in a certain browser. We don't need a browser to do unit testing. So we're minute 18. So I think that's almost exactly the same. Right. So this talk is about getting faster. So far we've seen ways of doing shallow rendering, and shallow rendering will get you a long way. In a couple of our service tests, when I first arrived, they had this test module that they had built. And this module was an Angular module that pulled in more or less any dependency that a test might need. So it pulled in every service, it pulled in pretty much every component, it pulled in most of the material library, and then they injected this into every single test so that they didn't have to add these mocks. And of course, this means that the tests are very easy to write, but on the downside, it makes them very slow. So for example, in one of the service tests, I deleted this dependency, and it didn't have any other dependencies, so I didn't even have to add anything, and the test time went from about 23 seconds for that service's unit tests down to about 5 seconds. So like, you want to try and minimize what you're passing in. And Angular will do tree shaking to try and reduce how much your dependencies affect things, but that tree shaking takes time. So it doesn't affect so much what you ship, but it very much affects what you're doing locally on your computer and how long your dev time takes, how long it takes to, for example, do a Webpack build of your entire system, these sorts of things, right? So has anybody here used Jest? Couple hands? So Jest is a really fantastic testing framework. It's fairly modern. It's made by Facebook, as everything seems to be these days. And it's really focused on making a better dev experience. There were some really interesting talks at Facebook's conference where they said one of their goals is they're trying to make their DevOps team, their team that helps their developers, better. Instead of it being a second-class team, they're looking for the smartest people to work on that team because they figure that every smart person they put on that team can save a lot of time for every other developer, right? And make all of them more efficient. So Jest does small things that you don't think about, but that make a lot of sense. So for example, when you run your tests, if one fails and it's the second to last test in your run, when you run them the next time, instead of running them in the same order, it says, oh, this failed last time, let's run that first. So it goes and puts that at the top. So you get feedback faster. Another thing that it does, it uses Git. So when you edit some code, it tries to determine which tests are likely affected by the code that you've edited. And it will run those tests first because they're the most likely to fail. So one of the patterns that I see is when I test with Jest, the tail end of my tests tends to always be green. My failures are always right at the beginning. So even if it takes 30 seconds or 45 seconds to run in Jest, my failures have happened in the first few seconds, which gives me a big advantage. It has a very good watch mode as well. It also can do something called snapshot testing, which we won't discuss so much tonight. But if you've ever thought about taking snapshots of the browser to see if it looks right and been driven crazy because a couple pixels change, snapshot testing essentially takes a snapshot of the DOM and then you can look at that instead. So it really helps with these sorts of tests. Something else that is really clever, it optimizes the test order. So I have a VM, and in that VM I have 2 cores, which means that I can't parallelize as much, right? And I had one test that's taking about 45 seconds to run, and all of the other ones combined take about 25 seconds to run, right? So one of the things that I notice happens is originally this long-running test was the last one to run, and I'm running on 2 cores, so I have 2 workers. And so Jest goes, oh, this one is taking much longer to run, so I'll run that one first, which means that it's running on one thread, and all of the other tests are running on another thread while that one's running, which means that we parallelize the work. So it learns how to sort them. We did a test where we split this one large file into 3 files, and it very quickly, the first couple tests take about 45 seconds, and it starts to reorder things and learn what the optimum order is, and before long, they're down to about 25 seconds. You know, and so it's really quite clever about trying to make your experience better. So, when we work with Angular and we want to use Jest, we of course need to install Jest. We have a couple other things that we're going to need. There's this justpreset Angular. This is a community package which helps to deal with some of the zone bindings in Angular, sets up the various things that are expected for Angular. And also we have our types. So since we're using TypeScript, we want to have the types for Jest. Right? Once we have that, we need to go and build a Jest config file. So we load up our editor. We need to tell it that we're using this preset. And then we need to say where to find our tests. So we specify all of our tests live in our source folder. In this case, our tests are living alongside our components as .spec.ts files. That is a setting that you can change, but that's configured for us in the Jest preset Angular because that's how most Angular projects are set up. Then we need to say where is our framework file, our setup file for the tests. And here we have a module mapper. So sometimes in Angular, you don't want to type //// and then some service. Instead, you want to say, look in services / my service, right? So in the Angular IO project, they have a special testing helpers folder, and they've mapped that. So instead of having to write // testing all over their tests, they just use this, they set up testing, and then we remap that to be source testing, and then whatever file or folder they're looking for, right? So pretty basic setup. The next thing that we need is we've referenced this setup.jest.ts file. We need to write that. It's 2 lines. It's not very difficult. We import our preset, and we set up some global mocks. So Jest is going to use JS DOM to run our tests. So we aren't going to be using Chrome, so we're going to need to mock a few things because there's some things that are in Chrome that are not in JS DOM. This is part of my mock file. I haven't put all of it here, but I've defined things like local storage and session storage to just be simple mocks. Luckily for you, you probably don't need to write this file because we can simply go online and we will find that inside of the Angular preset, they have an example, and inside of that example, you can just copy paste this. So for the project that I'm working on, it was enough to copy paste this. For the Angular IO project, me and David spent a little bit longer adding some more mocks. There are some scroll things and things that are not in here. So Shall we give Jest a try and see how much time we can save just by importing it? Right. So once again, we run the same config check. I'm not cheating. I've left their extra 2 seconds in so that you could delete that and get 2 seconds extra. Right, so we can see that it has an estimate based on previous runs. We can see that it's running this app component right from the beginning. So this app component is the really big test, and you can see that it's running the other ones in parallel to it. I have 4 cores on this computer, so it's using 3 threads. By default, it drops down by 1. You can configure it to use all of your cores. The running joke in the team next to us is that they can hear when we're testing because you hear the fans spin up on all of the computers. So this component we can see is taking much longer than all of the other tests combined. So something that's important to understand, when you switch to Jest, each of your spec files is a unit. It will not split up your spec files, but it will run individual spec files in parallel with other spec files, right? So one of the things that we thought is we can probably get some gain if we split this file up, right? So we're down to 43 seconds, so we've knocked roughly 30 seconds out of the test time that we had. So that's pretty good. And this is on the Angular tests. These are the ones that are coming from the people making Angular, which I hope are hopefully among the best tests in the world for Angular. Right? So we've done something. What did I have to do this? Well, I want to be clear. If you're starting a new project with Angular, I would not even start with Karma. I would start directly with Jest. All of these changes are things that you need to do in order to switch from Jasmine, which is what Karma is using, to using Jest. Jest has its own spies and everything built in. I don't want to go through each of these, but you can just see that each of them has an individual thing. I will mention a couple. This Jest spy-on versus the old Angular spy-on is a little bit tricky. So the Angular spy-on, it replaces the function that it's spying on by default, where the Jest one just spies on it. So if you don't forget that, it's easy to fix. You just use this one down here and return a mock implementation, and then it's stubbed. But originally in Jasmine, it will not call the one underneath, where in Jest it will. So that is a very big difference that you need to go through and kind of manually fix. The other one to watch out for is the way that calls work. So when we have a spy, in Jasmine, we can do calls and get like the most recent, that sort of thing. In Jest, this is just a double array. So you can see it's one array and then a second one. And it's under the .mock. So you need to add the .mock, and you just need to use either the length. You can write some helpers for this if you want, but it is fairly basic. There's a few traps. With Jest, the spy-on doesn't replace the function. There's some differences in how we deal with the mocks, like I pointed out. The other one is JS DOM does not support certain things. You can absolutely stub these. This is what we saw in our global mocks file. We've had no trouble doing that. Another little kind of gotcha, and I wanted to have these 2 slides here because I've spent a lot of time Googling in the last few weeks trying to find why does this not work or why does that not work, and digging in and going through code. And these 2 slides are intended to kind of help you guys out. So if you decide to do this, that you won't have to spend those same hours. You can just have a little reference sheet, right? And so replacing spies also is not resetting them. So the calls count will remain in Jest. In Jasmine, it actually resets the call count. So all you have to do is call reset after you replace it as well. So it's just 1 extra line of code. So this is our results. We ran this on my buddy's Mac. I've also run it on Linux. We have very similar results. We just saw it running on Windows. So this is for the Angular I/O tests. We go from over 60 seconds in most of them. This one's a little bit faster. And then we have a puppeteer comparison. We can see puppeteer is ever so slightly faster, but you're not really getting big gains. Just running Jest, not rewriting any tests. We almost cut the time close to in half, bit more than half, less than 2/3. And when we actually split that file, we look at what are we spending all of our time on and split it up, we can save even more. And I can just show that. So now what we've done is we've split that one really long file into 3. So we've repeated some work here. We're actually doing more work than we were before, because now we're instantiating all of the tests multiple times. We have to compile that component more, that sort of thing. But on the plus side, we can parallelize that. So you can see that Jest has decided that the best thing it can do is run these 2, which are very long running, at the same time, and then use one thread for all of the other tests. And so it's quite clever. It goes and tries to figure out how to pack all of your tests onto the workers that it has. Right, 37 seconds. So that's a pretty big improvement from where we started tonight. We were 1 minute 18 when we started. We've done pretty good. I wanted to mention a couple of disadvantages. I think the biggest one in my mind is that it's harder to find examples for how to test Angular with Jest. So if you're very new to writing Angular and very new to testing, this might be a difficult thing for you. It might be a deal breaker. But in general, it is going to be harder to find examples because not as many people are doing this. You might need to extend JS DOM. We've had to add some scroll support and some window worker support. But once again, all we did there is add empty mocks. So once you find the thing that's missing, it's a couple of minutes of work. The other thing that I was discussing this with one of my buddies last night, and he said, yeah, but nobody will visit your page with JS DOM. At least if you're testing in Chrome, maybe you will find something that one of your users will see. And the thing that I would say to that is, yes, you're absolutely right. That is in some way a disadvantage, but that's why I write integration tests. And we will leave that for another talk. But I would argue that if you're writing unit tests, we're not interested in which browser, because then you should also run them on IE and on Firefox and on Edge and whatever else, right? And so this is a disadvantage in some way, but I would say it's not our focus for these tests. So this would not be possible without the Jest preset Angular, so I've put a link to it here. I think it's really a great tool and one that I'm really thankful that it exists. So I can smell pizza if anybody is hungry. We can have a question over a beer. All right. Thanks so much, guys.